know how waves behave and what would happen if a wave passing through, let's say, two slits would behave. They knew that they will see an interference pattern. If the waves are coming from a source of light, then it will be visible an interference pattern as the one shown. Bonds of light and bonds of no light. If instead of light passing through the slits, we now have particles, meaning mass, which, let me say, particles are very, very small, then the expected pattern will be as the one shown. When the two slits experiment was performed using particles, the actual observed pattern was that, like if we had used light instead of particles, we got wave behavior. Then they did the experiment again, this time putting particle detectors on each slit to know the exact moment in which the particle passed through the slit. Other than that, it was the same experiment. You will think that you will get a wave pattern like the previous experiment, but they observed a particle pattern. There was a remarkable finding. Particles exhibit a dual behavior. Wave-like when they are not observed, and particle-like when they are observed. It's like how children behave when they are not watched by their parents, and on the contrary, how they act when their parents are watching them. The experiment brought to light the duality of mass. That means that mass can behave both as a wave and as a particle. The wave-particle duality applies to micro and macro levels. We people also experience this duality, but these changes are too small that we can't really perceive them. They are on a very, very small scale called quantum, where these behaviors are more evident. The implications of the findings of the double-slit experiment are profound. The observed is not independent from the observer, which makes us question all other experiments.